In the year 1855, inside one of the most luxurious palaces in France, Emperor Napoleon III hosted a lavish state banquet. Ministers, generals, foreign ambassadors, the most powerful people in Europe were all seated around the same table. Everything reflected wealth: the crystal, the chandeliers, the silver, the gold. But none of those was the most valuable thing in the room. As dinner began, the emperor's most honored guests were handed cutlery made from a strange silvery metal. The less important guests received gold. Yes, gold. Because in that moment, gold was considered the cheaper option. The mysterious metal was aluminum. Today, you crush it in your hand after finishing a soda. You wrap food in it. Throw it into a recycling bin and never think about it again. But in the 19th century, a small piece of aluminum could be worth more than the same weight of gold. How? How could one of the most common metals on Earth become one of the most expensive? Why would emperors treasure it more than precious metals? And how did it go from royal dining tables to disposable drink cans in little more than a century? The strangest part is that aluminum was never rare. It was everywhere. Locked inside mountains, hidden in ordinary rocks, buried beneath fields. Even beneath the streets, people walked on every day. Humanity had been surrounded by it for thousands of years, without realizing it. Nature had played a remarkable trick. It gave humanity an almost endless supply of one of the most useful metals ever created, then hid it behind a chemical lock so powerful that no civilization could break it. Not the Egyptians, not the Greeks, not the Romans, not even the greatest empires in history. For centuries, people mined gold, they forged iron, they cast bronze. But aluminum remained imprisoned inside stone, invisible, untouchable, almost as if it didn't exist. Then, everything changed. Not because someone discovered a new mountain or a richer mine, but because a handful of scientists refused to believe that nature's lock could never be opened. The race to free aluminum would transform science, create billion-dollar industries, change the future of transportation, and eventually put one of history's greatest treasures into your pocket for the price of a soft drink. But before aluminum became the metal of airplanes, skyscrapers, and smartphones, it was something else entirely, a mystery. To understand why, we have to travel back to a time when no one even knew this metal existed. Long before humanity built skyscrapers, crossed oceans by air, or sent satellites into space, people already knew gold, silver, copper, iron. Metal shaped civilization. Empires rose with it. Wars were fought over it. Kings measured their wealth by it. But one metal was missing. Not because it wasn't there. It was, in fact, it was everywhere. Hidden inside ordinary rocks, mixed into common clay, buried beneath forests, mountains, and deserts. It was the most abundant metal in Earth's crust. Yet for thousands of years, no one ever saw it. Nature had hidden aluminum in plain sight. Every atom was locked tightly to oxygen, a bond so strong that fire couldn't break it. Hammers couldn't free it, and even the hottest furnaces were powerless against it. It was like trying to steal a prisoner from a vault without knowing where the key was. Ancient civilizations used the rocks that contained aluminum without realizing it. The Egyptians mixed alum into cosmetics, medicines, and fabrics. The Romans used it to dye cloth and preserve leather. They touched aluminum every single day. They simply didn't know it. For nearly 2,000 years, the metal remained a secret. Not because it was rare, but because chemistry hadn't caught up with nature. Then came the age of science. By the late 18th century, European chemists stopped asking, "What can this mineral do?" They began asking, "What is it made of?" That single question changed everything. In 1782, the French chemist Antoine Lavoisier studied a strange white substance. He believed it contained an unknown metal, one no human had ever seen. But there was a problem. He couldn't prove it. He knew something was trapped inside. He just had no way to set it free. Years later, a young British scientist named Humphrey Davy tried to solve the mystery. Electricity had begun revealing secrets no one thought possible. Davy believed it could unlock this one too. He experimented, again and again and again. Every attempt failed. The metal stayed hidden. But even in failure, Davy changed history, because he gave the mystery a name. At first, he called it aluminum. Later, he changed it to aluminum. Across much of Europe, the name eventually became aluminium. The spelling changed, the pronunciation changed. But one thing didn't. No one had actually seen the metal. Imagine that. A metal with a name, a scientific theory, and growing excitement, all before anyone could hold it in their hands. It was almost a ghost. Everyone believed it existed. No one could reach it. Then, in 1825, a Danish scientist would finally do what the greatest chemists in Europe could not. For the first time in history, humanity would catch a tiny glimpse of the metal that would one day change the modern world. In 1825, a young Danish physicist named Hans Christian Ørsted succeeded where generations of scientists had failed. For the first time, he produced a tiny amount of aluminum. It wasn't a bar, it wasn't a sheet, it wasn't even a usable piece of metal, just a few tiny grains. But those grains changed history, because they proved aluminum was real. 2 years later, a German chemist named Friedrich Wöhler improved the process. He produced purer samples, studied them, weighed them, measured their properties, and discovered something extraordinary. The metal was remarkably light, far lighter than iron, yet surprisingly strong. And unlike iron, it didn't rust away. Scientists were fascinated, but there was one problem. Producing even a few grams required days of work, rare chemicals, and enormous expense. Every experiment cost a fortune. Every tiny sample was treated like a priceless jewel. Then came the Great Exposition of Paris in 1855. The world gathered to see the future. Steam engines, new machines, industrial wonders. And inside one display case, visitors stopped in complete disbelief. There, protected behind glass, sat several small pieces of aluminum. Not because they were beautiful, not because they were large, but because they were almost impossible to make. Newspapers called it a miracle metal. Visitors stared at it the way people stare at diamonds. Among those visitors was Emperor Napoleon III. He became obsessed. Not with gold, not with silver, with aluminum. He ordered craftsmen to make cups, plates, and cutlery from the new metal. But there wasn't enough for everyone, so he reserved them for his most honored guests. Everyone else, including nobles, ate with gold instead. Imagine sitting at that dinner table. The guests holding gold would secretly envy the guests holding aluminum. For one brief moment in history, the world's most ordinary metal had become its greatest luxury. But luxury has a weakness. It survives only while something remains rare. And somewhere far from royal palaces, 2 young men were about to destroy aluminum's value forever. Neither knew the other existed. Yet, in the very same year, they would make exactly the same discovery. A discovery that would flood the world with aluminum and turn an emperor's treasure into something you could throw away without a second thought. The year was 1886. 2 young men separated by an ocean were chasing the exact same dream. Neither had met. Neither had written to the other. Neither had any idea that history was about to choose both of them. In the United States, a 22-year-old student named Charles Martin Hall worked inside a small wooden shed behind his family's house. It wasn't a famous laboratory. It wasn't funded by the government. Just a furnace, a handful of homemade equipment, and one impossible ambition: to free aluminum from the rock that had imprisoned it for millions of years. At almost the exact same time, more than 3,000 miles away, a young French engineer named Paul Héroult was chasing the very same solution. Different country, different language, different life. The same question: how do you make aluminum cheap enough for the world? For decades, scientists had managed to produce aluminum, but only in tiny amounts. Every gram cost a fortune. Every experiment consumed expensive chemicals. The metal remained a luxury. Hall and Héroult wanted something different, not a scientific curiosity, a manufacturing process. One that could produce not grams, but tons. They stopped asking how to break the bond. Instead, they asked what if electricity could do the work for us. It was a radical idea. Electricity was still changing the world. Cities were only beginning to light their streets. Most people had never seen an electric light bulb. Yet these two young men wanted electricity to create metal. Their solution was astonishingly elegant. They dissolved aluminum oxide inside molten cryolite, then passed an enormous electric current through the liquid. Slowly, silently, pure aluminum began collecting at the bottom of the cell. For the first time in history, the metal could be produced efficiently, reliably, on an industrial scale. History remembers it as the Hall-Héroult process. More than a century later, it is still the foundation of almost all aluminum production around the world. Some inventions change history. This one never stopped. Almost overnight, the impossible became practical. Factories appeared, production exploded, and the price collapsed. Within a few decades, aluminum lost more than 90% of its value. The metal that emperors once locked away could now be purchased by ordinary people. Napoleon III had treated aluminum like a royal treasure. Now it was becoming an industrial material, not because the metal had changed, but because humanity had finally discovered the key to nature's lock. There was only one catch. The new process consumed an astonishing amount of electricity. Suddenly, the world's most valuable resource wasn't aluminum. It was power. Because whoever controlled electricity would control the metal that was about to build the modern world. But there is one more detail. Charles Hall and Paul Héroult never met. One was born in the United States, the other in France. They worked an ocean apart, yet they were born in the exact same year, 1863. They made the exact same breakthrough in the exact same year, 1886. And nearly 3 decades later, they both died in the exact same year, 1914. Two lives running in parallel, never crossing. Yet together they unlocked a metal that transformed the modern world. By the end of the 19th century, the greatest challenge was no longer making aluminum. It was making enough of it. Every new aluminum plant had the same appetite: electricity. Not a little, not a lot, an unbelievable amount. Producing aluminum consumed more power than almost any other manufacturing process on Earth. So the factories moved, not toward cities, not toward ports, but toward rivers, where waterfalls could turn turbines, and turbines could generate electricity day and night. The future of aluminum would be written by water. How? As production grew, the impossible happened. The metal that emperors once displayed like a crown jewel began appearing in ordinary workshops. Engineers loved it. It was light, strong, resistant to corrosion, easy to shape. For the first time, they could build machines without making them unnecessarily heavy. Then a new invention changed everything: the airplane. Early aircraft had one overwhelming enemy: weight. Every extra kilogram made flight harder. Every unnecessary pound reduced range, reduced speed, reduced the chance of getting off the ground at all. Aluminum solved that problem. It wasn't perfect, but it offered something almost no other metal could: strength without crushing weight. Within a few decades, it became the backbone of aviation. Then came the First World War, and after that, the Second. Suddenly, aluminum was no longer just another industrial metal. It became a strategic resource. Governments measured it, protected it, fought to secure it. Because without aluminum, there were no modern aircraft. And without aircraft, there was no air superiority. Factories that once produced kitchenware were transformed into factories building wings, fuselages, engines, entire fleets. The same metal that had once been served at an emperor's dinner table was now flying across battlefields. By the end of the war, the world had learned a lesson it would never forget. Aluminum wasn't simply a luxury or even a useful metal. It had become essential to transportation, to engineering, to industry, to the modern world itself. But history had one more surprise. After helping win wars, aluminum would find its greatest success not in the sky, but in your hand, inside supermarkets, inside kitchens, inside refrigerators. The world's most valuable metal was about to become disposable. The wars ended. The factories didn't. For years, they had produced aluminum as fast as they could, for fighter planes, bombers, military equipment. Now those wars were over, but the factories were still standing, and they still needed a purpose. So aluminum left the battlefield and entered everyday life. Not all at once. Quietly, almost unnoticed. It appeared in window frames, kitchen utensils, power lines, bicycles, cars, construction, even the chair you might be sitting on right now. Without realizing it, the world had become wrapped in aluminum. Then came one of the smallest inventions with one of the biggest impacts, the aluminum beverage can. Before it, most drinks were sold in heavy glass bottles. They were expensive to transport, easy to break, difficult to store. Aluminum changed everything. It was light, strong, cheap to shape, easy to stack. And unlike glass, it didn't shatter. Within a few decades, billions of cans were being produced every single year. People carried them, opened them, finished their drink, crushed the can, and threw it away, never realizing they had just discarded a metal that emperors once treated like treasure. But aluminum had one more advantage, one that made it unlike almost every other metal. It could be recycled again and again and again without losing its quality. The can in your hand today could become another can, then another, then another. Decades later, the same atoms, the same metal, a completely different life. Even more remarkable, recycling aluminum uses only about 5% of the energy required to produce it from raw ore. That means the hardest part isn't recycling aluminum, it's making it for the first time. Today, nearly 3/4 of all the aluminum ever produced is still somewhere around us. In buildings, in airplanes, in power grids, in cars, in cans. Still working, still useful, still refusing to disappear. But perhaps the strangest part isn't how valuable aluminum became, it's how ordinary it feels today. Because the greatest inventions don't always remain luxuries. Sometimes they become so common that we stop noticing them entirely. There is just one final twist to this story. Because aluminum didn't simply change the modern world, it changed the way we think about value itself. Take a look around you. Not tomorrow, not when you leave the house, right now. There is a good chance that aluminum is within arm's reach. In your phone, your laptop, the window beside you, the car outside, the power lines above your street. Even the can you almost threw away without thinking. Less than 200 years ago, owning a piece of aluminum meant you were among the wealthiest people alive. Today, children crush it, factories recycle it, and billions of people use it every single day without giving it a second thought. And that may be the strangest part of this entire story. Aluminum never became less extraordinary. We simply became used to it. Think about it. The same metal that once sat on an emperor's dining table now flies 30,000 feet above your head, crosses oceans, carries electricity across entire continents, protects food, builds skyscrapers, travels into space, and quietly keeps the modern world running. Yet for thousands of years, humanity walked directly above it. Every civilization stepped on it. Every empire built upon it. Every king ruled over it. None of them could reach it, not because it was hidden, but because they didn't yet have the knowledge. Perhaps that is the real lesson of aluminum. The world's greatest treasures are not always the rarest ones.
Sometimes they surround us every single day, waiting for the right idea to unlock them.
Gold made kings wealthy. Iron built empires. Oil powered the 20th century. But aluminum quietly became the metal that made the modern world possible. Without it, airplanes would be heavier, power grids far less efficient, space exploration far more difficult. Even the device you're watching this on would look very different. A metal once worth more than gold, now wrapped around a sandwich, folded into kitchen foil, dropped into recycling bins, forgotten. Not because it lost its value, but because it became part of everyday life. Maybe that is how the greatest inventions always end. Not as miracles, not as luxuries, but as ordinary things so deeply woven into our lives that we stop noticing how extraordinary they really are. And perhaps the next time you hold an aluminum can, you'll remember that you are holding a metal that emperors once treasured more than gold.